So structures retaining water. So in this lecture we'll be seeing some of the structures which retains water. Retains म्हणजे stores water. Okay. So one of such structure that we see in our civil engineering industry is called as a dam. Okay. So first we will define what is dam. So right now dam is a structure. Dam is a structure which retains which retains or stores water on one side. So we'll try to draw the diagram here of a dam. So basically a dam is nothing but a wall which is restricting the flow of water. Now this is the dam. Okay, this is the length of the dam. It is extending here. And as we know, for what purpose dam is used? Dam is used to store the water. So this is the level of water. Water level is shown by this symbol. Now this water is spread across the length. Now as you can see, there is water present on one side of the dam. There is water which is present on one side of the dam. So what happens is that this water exerts some pressure on this dam. It will exert some pressure on the dam. So the next point we'll write about water pressure. So the pressure which is exerted by water is called as water pressure. Now here one point we should understand, that the water pressure distribution. In hydraulics you must have learned about hydrostatic pressure. So same thing we have to use here. The water pressure distribution is triangular. Whatever the distribution of water pressure is there, how is the distribution? That distribution is triangular in shape. So what do you mean by triangular in shape? So we will draw it here in this diagram. So up to this height water is present, up to this height. Now to understand what is the pressure here, the pressure at the top, the pressure at the top surface of water is 0, and as we will go down, the pressure will keep on increasing. So if we just draw here one diagram, it will resemble a triangle. Hence this point is relevant, that is water pressure distribution is triangular. That means the pressure at the top surface, the pressure at the top surface is 0. The pressure at the top surface is 0. And what is the pressure at the bottom surface? This value is equal to gamma into small h. Now from here we have to pay attention to the each and every units that we are using here. Now whatever is the total height of dam, जे काही total height असेल dam ची, that will represent it with capital H, overall height. Now here you can see the water is not present up to the top level of the dam, it is present up to certain height. So that height is called as small h. So this is small h. Okay. This gamma value, it is called as unit weight of water. Unit weight of water. I hope it is clear. Now Due to this water pressure, as we have seen in the wind pressure, there is one resultant force which is exerted on the dam. Whatever is this white color structure you can see, or the dam, this will be under one external resultant force due to the water. So we'll denote that force by the symbol P. Now this P is called as resultant lateral thrust. This P is called as resultant lateral thrust. Now the formula for P is same, that is pressure into area. But as we can see, the pressure variation here is from 0 to gamma h. So it is linearly increasing. So here we will be taking average pressure. So इथे आपण घेऊ average pressure. So P is equal to average pressure multiplied by area. Average pressure multiplied by area. आता average pressure करायला म्हणजे 0 plus gamma h divided by 2. So this is the average pressure multiplied by the cross sectional area. Now here the cross sectional area we will be taking as h, small h, multiplied by the length of the dam. ठीक आहे, जे कॉन्टॅक्ट मध्ये आहे सरफेस तेवढाच एरिया आपल्याला घ्यावा लागेल. वॉट एव्हर द एरिया ऑफ डॅम इज इन कॉन्टॅक्ट विथ वॉटर, that we have to take. So here it will be h into capital L. But now here one point you have to write it down. Note, we will always consider unit length of dam. That means we will be taking L value as 1. Okay, we will be taking it as 1 meter. So what will be the area now? So area A will be h into 1, that is h. So we'll write here h into 1. So what is the resultant lateral thrust? It is equal to half gamma h square. So this is the value of resultant lateral thrust. Now the second question is that at what distance it is acting from the base. This is the base level. From the base, what is the height of the resultant lateral thrust? So we can clearly see that this is a triangle. Okay, so for triangle, the centroid acts at a distance of 1/3 of the total height from the base. So total height is h here, small h. So this distance will be small h divided by 3. So this force act at a distance of h/3 from base. Now in the next lecture we will be seeing what is rectangular dam, what is trapezoidal dam, and then we will see the analysis of rectangular dam.